All right, ladies and gentlemen, welcome back. We're looking at circulation part two. This is all about the cardiac cycle and blood pressure. So here's just a little example of heart, and we'll explain why this can actually happen in a minute. So the reason why that was able to happen is because the heart has these things called nodes. And what it is it's specialized nervous tissue within the heart that is able to work independently of the brain. So even though that heart was removed from the fish, it was still able to beat because these nodes produce nervous signals. So first of all, there's two nodes. There's the SA node and the AV node, and we'll talk about what those mean in just a second. Just like I said, they have the ability to contract independently. And the first one's called the sinoatrial node. So that's this one right up here. It's along the wall of the atrium, so right here. And we also call that the pacemaker because this is what determines when the heart's going to beat. And we also have another one called the atrioventricle. It's named on this because it's right on the wall in between the atrium, right atrium and right ventricle. It's a little bit closer to the inside of the heart. Okay, continuing on. This is the actual cycle. So we call this the cycle because it comes back to the beginning again. So it's kind of a step-by-step process of what's happening. So the first thing you need to know is this SA node, or the pacemaker, initiates the contraction of the heart. So what that means is once the atrium, so the right atrium, fills with blood, it stimulates the contraction of that atria. So once it fills up here, this SA node causes it to contract, and it squeezes the blood through our valve here and into the right ventricle. So you might want to just pause it here so you can write it down. A split second later, the SA node here sends a signal to the AV node to contract. So what happens is this blood gets pushed because of this contraction of the right ventricle up and through the semilunar valve, and it gets pushed out to the lungs. And just another little note of interest, the double beat of our heart, it's not actually due to the contracting of the heart. The double beats is the valves closing. So once the blood goes through these valves and it stops beating, the valves slam shut, and that's the thub-thub that you guys hear. So the Purkinje fibers are a special network of fibers, nervous fibers, that help contract these ventricles. As you can see, the ventricles are pretty thick and they're pretty big. And so the node initially isn't enough to make all these contract. And so all of these network of nervous fibers here contribute to that contraction. So it's the set of nerves at the AV node that sends the impulse through these ventricles. So autonomic regulation. We've talked about the medulla oblongata before, and what this does, it doesn't initiate, so it does not initiate the contraction. That's that sinoatrial node, but what it does is it can govern the heart rate, so it can make it go faster or slower. Okay, and it does that by sending signals to the SA node. So blood pressure. So we have this little device here, a sphygmomanometer, which we're going to be using in the near future when we do our blood pressure lab. And what it does is it tests the amount of pressure that's pushing against each of the vessel walls. And one thing that we should know is that the pressure is greater when the ventricles contract than at rest, which makes sense. Just like when you squeeze your hand, the pressure on your skin is a lot more than when it's relaxed. So we have two types of pressures. We have systolic and the diastolic, and they both relate to two different things. The systolic is the pressure when the ventricles contract. So when the ventricles are contracting, that's a certain amount of pressure, and then we compare that to the diastolic, which is the pressure when the ventricles are at rest. So a pretty normal systolic diastolic is 120 over 80, or 120/80, and we measure that in millimeters of mercury, so that's a pressure. anything higher or lower than that can cause some severe health problems, which we'll get into in a little bit. So here are some of the problems. So we have this stuff that's called plaque. And what it is, it's the hardening of the arteries. So there's two words, arterial sclerosis and atherosclerosis. They're both very similar in their appearance, their sound, and actually in terms of what they are. So arterial sclerosis is kind of like the big, broad, overarching concept, and that's just the hardening of a blood vessel. But usually it's due to cholesterol or plaque building up on those arteries, and that is called atherosclerosis. So arterial sclerosis is the hardening, atherosclerosis is the plaque building up. Okay, so hopefully that distinguishes enough. A lot of people just use them almost interchangeably. So what this can do is if you have hard blood vessels, it causes high blood pressure or tissue death, and it can even contribute to complete blockages of those vessels. Okay, and we know that if there's no blood going to certain areas because of a blockage, those cells there will die because they don't have the oxygen in order to be able to produce energy. If this happens in some of the coronary arteries, that can lead to a heart attack. So the arteries that are on our heart, that does not look like that, if there's any blockages in those, that's what's going to cause you to have a heart attack. And it's actually called a myocardial infarction. That's what a heart attack is. It's called an MI. Okay, finishing off here. Other things that can cause high blood pressure, we're going to see this a lot in the excretion unit, and it's high salt diet. So if we have salt, what that does is, as we know because of osmosis and diffusion, is that water wants to go to areas of high concentrated solute. So water wants to go to high solute concentration. So for example, if there's lots of salt in a blood vessel, water from our tissues is going to want to absorb or move into those vessels. And we know that if more water is increasing, there's going to be more volume. So more water equals more volume. And if it's the same size vessel, it's going to increase the pressure. Okay? So what we call this is hypertension. So hypertension is high blood pressure. And the other thing is hypotension is low blood pressure. And this can affect kidney filtration, which we'll get into more when we talked about the excretion system. And then the last thing is that the medulla also has a regulatory ability to either dilate, which means make bigger, or constrict blood vessels depending on the blood pressure of arterioles. Okay, so what should we be able to know? We have to make sure that we know what's occurring during the cardiac cycle. So in terms of SA contracting, the AV contracting, Purkinje, making sure we know what that means. And then also know all the blood pressure terms. Okay, and if you have any questions, make sure you write them down. Have a wonderful night.